Okay, so this is section 11.3, problem number 8. And in this problem, you are determining the value of the determinant. It happens to be a 3 by 3 because it's 3 rows and 3 columns. So there's a specific formula for evaluating the determinant value of a 3 by 3, and it goes like this. It has to do with constructing minors, what are called minor determinants, which will be 2 by 2s. So here we go. Doing this determinant, we are going to be using the values that are in row 1 as part of our coefficient, and the formula goes like this. Starts off with -1 each time, which is going to be raised to a certain power, and we're going to determine that by talking about the entry that we're using from row 1. We're only going to be using these each time I expand by the minors. So we're going to use row 1, column 1. You add up these subscripts, 1 plus 1 is 2, and that becomes the power on the -1, while taking the entry from the actual determinant from row 1, column 1, which is a 5. That gets multiplied by the minor that we're going to construct, the minor determinant. And the minor determinant, how you're going to get that is you're going to, again, refer to these little subscripts here. You're going to take out row 1, column 1. Take out row 1, take out column 1. And that'll leave you with just these 4 numbers, -5, 2, 4, 3. -5, 2, 4, 3. And in this way you construct what's called a minor determinant. Okay, go again. It always starts off with -1, so I'm going to put a plus, then I'm going to put -1. I always put a plus in between the minors that I'm setting up. So it starts off with -1. We're going to raise that to a power, and the power is going to come from the next entry that we use, which is going to be row 1, column 2. You're using, again, just these entries as part of the coefficients. So you always have a -1, then you'll select the next value in row 1, which happens to be a 4. That entry is in row 1, column 2. So this little description of the row and the column, you add those up to get the power that goes on the -1. Every single time you set up a minor. This will be the coefficient of the value we get from this minor determinant. We're going to get the minor determinant again by referring to these subscripts. We're going to take out row 1, and we're also going to take out column 2. So removing row 1, removing column 2, that leaves us with 1, 2, 1, 3. Taking out row 1, column 2. 1, 2, 1, 3 is what's left over. Whoops, it should be a 2, and then 1, 3. Okay, moving to the next term. Again, start off with a -1, which we're going to raise to a power. That power is going to be determined by the next entry that we grab from row 1. Moving up here, we are now moving on to row 1, column 3. I would label it just so you can help yourself focus, because these two numbers determine, when you add them up, the power on the -1, and they also tell you what row and column to take out when you construct your minor determinant. Take out row 1, take out column 3. So just visually kind of concentrate on taking these numbers out, excluding them, and excluding these numbers. So if those are gone and these are gone, that leaves you with 1, -5, 1, 4. 1, -5, 1, 4. Okay, and then using your skills from how to calculate the determinant for a 2 by 2, we're going to get the value for each one of these and add them together. Okay, so at this particular point, we're going to concentrate on the values that we get for each expression. So -1 to any even power is +1. +1 times 5, 5. That will be multiplied by the value of this determinant right here. Always when you're doing the value of a 2 by 2, do the downward product first. Move down on the diagonal doing that product first, which would be -15, followed immediately by a minus sign. Now do the upward product on the diagonal. That would be an 8. I'm just going to set all these up and I'll come back and evaluate them. You can use your calculator at that point. Okay, now we're going to go -1. -1 raised to any odd power is -1. -1 times 4, -4. And that coefficient will be multiplied by the value of this determinant. So -4. Value of the determinant, do the downward diagonal product first, which is 3. Then do the upward. And don't forget, immediately put a minus sign. Then do the upward diagonal product, which would be 2. Moving on to the last term, -1 raised to any even power is going to be +1. +1 times -4, -4. Times whatever you get for this, the value of this minor determinant. Again, do the downward diagonal product first, immediately followed by a minus sign, and then do the upward product. This would be -5. Then come back and calculate each one of these values. Okay, so this is going to be -15, take away 8, that would be -23 multiplied by the 5 that's right out here. So 5 times 23, okay, that's going to be 5 times -23, that's -115. And then here it's 3 take away 2 is 1. 1 times -4 is -4. Okay, then next, this last one is 4 plus 5. That's a 9. 9 times -4 is -36. So the value of this 3 by 3 determinant as we calculate the last step. So it's -115 minus 4 minus 36. And that turns out to be -155 for the final answer. And that's how you're going to calculate a 3 by 3 determinant, which is pretty much the point of all of the problems that you asked me how to do. 8, 10, and 12. Moving on to number 12. I think, let's see. Yeah, number 10, that is a very long problem because in that problem, I believe you were using Kramer's rule. And Kramer's rule involves a lot of steps. It is not the quickest way to do a problem, but you have to be able to demonstrate on the test that you also know how to do Kramer's rule. Okay, so let's see. Here we go. Okay, first thing, Kramer's rule involves actually 4 determinants. They're all going to be 3 by 3, so they all have a lot of steps just for that part. But the main determinant, the main determinant value, which is going to play the role of the denominator, because in this problem to find x, y, and z. When you find x, you have to find it like this. Determinant of x over the main determinant. When you find y, you have to go d of y over the main determinant. And when you find z by Kramer's rule, you have to find determinant of y over the main determinant. So that means you need 4 different 3 by 3 determinants. Let's construct the first one, which plays the role of the denominator. So that has to do with the coefficient determinant, made only out of these coefficients. So 1, 1, -1. Then 1, -1, 4. And then 1, 5, -1. 1, 5, -1. Okay, let me check those real quick. 1, 1, -1. 1, negative 1, 4, and 1, 5, negative 1. So we're going to find the value of that. We're also going to find, create what's called the X determinant, and the X determinant would be this determinant, only the X column that you see right here, because in a determinant the first column is X, the first column stands for the Y values, and the last column stands for the coefficient of the Z values. So everything you see right here, those are all the X coefficients. Everything you see here are all the Y coefficients, and these are the Z coefficients. So when you're trying to create the determinant that is based on, that will help you to find the X solution, you replace the very first column of the main determinant with these constants. Okay, so we're going to use these each time we go to construct d of x, d of y, and d of z. And excuse me, please fix this. That should say d of z. Please fix that. Okay, so here's my d of x determinant. You take this column that represents the x's and replace it with these constants. Okay, so negative 7, negative 4, negative 23. And all the rest of the values, the y column and the z coefficients, put those right back. So 1, negative 1, 5, and then negative 1, 4, and negative 1. Okay, 2 more determinants that have to be set up. There's the one called the determinant in terms of y. And when we go to set up this determinant, again, we look at this main determinant, only we take the y column and replace it by these constants. Okay, so first column stays as is, the coefficients for x. Because we're doing the y determinant, you're going to replace this y column with these constants. So negative 7, negative 4, negative 23. So basically each time you set up a new determinant that has a subscript of some sort, you are replacing that column with these constants. Don't forget to put this last column in, which was negative 1, 4, and negative 1. Okay, then going on to create d of z. This time we're going to replace the z column with these constants. So negative 7, negative 4, negative 23. So I just put those constants in the z column and then keep the x coefficients and the y coefficients as is. Okay, now there's calculating the value for each one of these, because remember, in the end, we're going to return to this. But there's a lot of values that you need in order to even be ready to do any of this. So ultimately, that's our game plan. So let's first do the determinant value for 3 by 3 using the same formula that I demonstrated for you in problem number 8. Okay, here we go. Remember that it starts off with a negative 1 raised to a particular power. And remember how we do the 3 by 3 values. We're using the values in the first row. First, we're going to use row 1, column 1. That's what's going to go right here. Row 1, column 1. Add up those two subscripts. It becomes the power on the negative 1. And don't forget, you are expanding by the minors. So you're creating a determinant that is a minor of the main one. And this smaller determinant, you're going to be taking out row 1, column 1. Take out row 1, take out column 1. If all those values are gone and all these are gone, that leaves negative 1, 4, 5, negative 1. Negative 1, 4, 5, negative 1. Okay, go on to the next term. Again, start with a negative 1, We're going to raise it to a power, which is suggested by the next term that we're going to use here, which is, if this was row 1, column 1, this will be row 1, column 2. Go grab that value from the main determinant, because remember, we're working on the main determinant. We're not working on any of these yet. Okay, so row 1, column 2, there is a 1 there. These subscripts, when you add them up, provide the power on the -1, and then you're going to multiply that by the minor determinant, where row 1 and column 2 are taken out. Okay, so taking out row 1, taking out column 2, that would leave you with 1, 4, 1, -1. Okay, moving to the next term. Again, always start it with -1. We're going to raise that to a power. If the last term was row 1, column 2, we will be using row 1, column 3. Adding up those powers gives you the power on the -1. Now go grab the value in row 1, column 3 of the main determinant, which is -1. And multiply that by the minor determinant, which is obtained by taking out all values in row 1 and all values in column 3. So if row 1 is gone and column 3 is gone, that leaves you with 1, -1, 1, 5. Okay, and if you want to go ahead and do that value before we go on to do d of x, d of y, and dz. Okay, so if we were going to do the value here, -1 to any even power is just +1. 1 times 1 is just 1. So we're going to be multiplying this times whatever we get here. Okay, so it's 1 times, we're not going to write the 1, we don't need to. The value of this determinant, just do the downward diagonal product first, always followed by a minus, and then the upward diagonal product. Okay, that gives you -19. Now let's go to this next term. -1 to any odd power is -1. -1 times 1 is -1. Whatever you get out here as the coefficient gets multiplied by this determinant value. Okay, determinant value, do the downward product first, diagonal product, that would be -1, followed by a minus sign, then do the upward diagonal product, which is 4. So you have -5 in here, but switch that sign of that -5 and it becomes +5. Okay, moving to this last term, -1 to any even power is +1. +1 times -1 is -1. And that will be multiplied by whatever we get here. So this coefficient always gets multiplied by the value of this minor determinant. Okay, getting that value, downward diagonal product first, followed by a minus sign, and then upward diagonal product, which is -1. This turns out to be 5 plus 1, which is 6, but then gets switched by virtue of that negative out front, which is -6. Okay, so the determinant value here ends up being -19 plus 5 minus 6. And that is -20. Okay, so we're going to be using this as the denominator when we ultimately go to find x, y, and z. See, it's the value on the bottom. Okay, now we need the numerators. We need d of x, d of y, and d of z. Now we've already set up those determinants. We just have to do the calculation of the value for each one of those. So moving now to d of x. Okay, you got to concentrate on the right determinant, the correct determinant as you go along. So we're using this one now. Remember that to evaluate a 3 by 3, it starts off with a -1 raised to a power. When you're doing these determinants and expanding by the minors, you're only using the values in row 1. So we'll go row 1, column 1, row 1, column 2, row 1, column 3. Right now I'm on row 1, column 1. That value is a -7. Okay, take those two subscripts, add them up. That provides the power on the -1, and it also tells you how to construct the minor determinant. We're going to take out row 1 and column 1. So taking out this row and this column would leave us with -1, 4, 5, -1. Moving to the next term, so it'll be plus. Get that -1 going first. We need a power on it, which will be suggested by the term that we grab now. We just used row 1, column 1. Now we're using row 1, column 2. So the number in that position is a 1. Adding up these subscripts gives us the power on that first -1 on that value right here. And then it also helps us to construct the minor determinant because it tells us to take out row 1 and column 2. So in this d of x determinant, if we take out all these values and all of the middle values, that'll leave us with -4, 4, -23, -1. -4, 4, -23, -1. Moving on to the third term. You're always going to have 3 terms when it's a 3 by 3 evaluation that you're doing. So on to the next one. Always starts off with a -1 raised to a power. That power is suggested by the term we're about to grab now, which was, let's see, we were on row 1, column 2. Now we're on row 1, column 3. Add up the 1 and the 3, you get the power on this value. And go grab the value in column 1, in row 1, column 3. So row 1, column 3, there's a -1 there, and construct the minor. So again, this subscript tells you to take out all of row 1, all of column 3. So if you're taking out this row and this column, it's going to be -4, -1, and -23, 5. Okay, once you get everything set up, go and calculate the value for each of these minor determinants multiplied by whatever coefficients out here. Okay, so -1 to any even power is just +1. +1 times -7 is -7, and this coefficient always gets multiplied by the value of the determinant. When you do a minor 2 by 2 determinant, it's downward diagonal product first, followed by a minus sign, then upward diagonal product. Okay, that ends up being -19 times -7. Okay, so that'd be 133. Okay, moving on to this term right here. -1 to any odd power is -1. -1 times 1, negative, multiplied by the value of this determinant. Do the downward diagonal product first, which is 4, minus upward diagonal product, which would be -92. Okay, so this ends up being 4 plus 92, which is 96, but with that negative out there, it becomes -96. Moving on to the third determinant. This would be +1 times -1 is negative, times the value of the determinant. Okay, do the downward diagonal product first, minus the upward diagonal product, which is 23. What you see inside here is -43, but by the time you apply this extra negative to what's already negative, it becomes +43. Okay, put these values together. The 133 minus 96 plus 43, and you end up getting an 80. Okay, so now we have 2 of the 4 determinants. Okay, we have a -20 for the main determinant value. We have an 80 for the D of X determinant. Now we're moving to D of Y. Get yourself focused on the Y determinant, which is right here. And we're going to go through this procedure again. Start off with a -1. You'll put a power on it. You're always multiplying this first term by row 1, column 1. So you have to go to the Y determinant right here, and in that position, row 1, column 1 is a 1. These subscripts, when added, give you the power on that -1 and also help you to construct the minor. We're going to take out row 1, column 1 in the Y determinant. Take out row 1, take out column 1. That leaves you with -4, 4, -23, -1. Okay, on to the next term, which always starts with a -1 that will raise to a power, but this time we're going to be grabbing row 1, column 2 from the Y determinant. Okay, so in row 1, column 2, there is a -7. These subscripts, when added, give you the power on the -1 and also help you to construct the minor. So we're going to take out row 1, column 2. Take out row 1, take out everything in column 2. Gone, gone. That leaves you with 1, 4, 1, -1. 1, 4, and then 1, -1. Okay, last term. Start with a -1. Then we're going to be using row 1, column 3 this time, so that gives you a power of 4 here. The actual entry in row 1, column 3 in the Y determinant is -1. Okay, and then construct that minor by taking out row 1 and column 3. So take out row 1, take out column 3. That leaves you with 1, -4, 1, -23. 1, -4, 1, -23. Okay, now go ahead and calculate these values, doing the coefficient first, then multiplying it by the minor determinant value in each of these 3 terms. Okay, so -1 to any even power is 1. 1 times 1 is 1, so it'll be 1 times the value of this determinant. That would be +4 minus, and then after the minus, that would be a -92. Okay, so this ends up being 4 plus 92, which is 96. Moving on to this next term. -1 to an odd power is -1. -1 times -7 is +7. And then that gets multiplied, this coefficient gets multiplied by this determinant value. So go downward first, followed by a minus sign, and then do the upward product, which is 4. Okay, so this ends up being a -5 times 7. Okay, and then this last term down here, -1 to an even power is 1. 1 times -1 is -1 times whatever you get for the determinant. So this would be -23 when you do that downward diagonal product, immediately followed by a minus sign, and then the upward diagonal product, which is -4. Okay, so this is -23 plus 4, which would be -19 for what you have inside the parentheses. -23 plus 4 is -19, but then this switches that sign to +19. So D of Y ends up being 96, take away 35 plus 19. Oops. Which is also 80. Okay, one more determinant value to go. Now we have to do D of Z. Then after we have all of these values, we can go back and we can do the actual solution for x, y, and z. Okay, we're going to be using this for d. We're going to be using this for d of x. We're going to be using this for d of y, and we need one more. So d of z, again, start off with those -1. We're going to be using row 1, column 1 here from the z determinant like we always do, and then constructing the minor, multiplying it by the minor. So in that particular determinant, the entry in row 1, column 1 is a 1. Okay, adding those subscripts right there. There's so many things that you could forget here. Got to be really careful. Have your head on straight. Try to concentrate. Okay, and if we take out row 1, column 1 from the z determinant, taking out row 1, column 1, that would leave us with -1, -4, 5, -23. Okay, moving on to the next term, again, starting off with that -1, going and getting the next entry from the z determinant, which would be row 1, column 2. And in that position, row 1, column 2, there's a 1, another 1. Okay, so you're going to put the 1 there, add up these subscripts, that provides the power on the -1, and construct the minor by taking out row 1, column 2. So in this z determinant, if we take out everything in row 1 and everything in column 2, that leaves us with 1, -4, 1, -23. Okay, last term for the z determinant. Start off again, -1. This time we're going to be taking row 1, column 3 entry, which is row 1, column 3, -7. Adding these subscripts gives you a 4, which provides the power on the -1. Those subscripts also help you to decide what to construct this minor out of. So we're taking out row 1 and column 3 this time. So taking out all of this row, all of this column leaves you with 1, -1, 1, 5. Okay. Just make sure I have that right. So we took out row 1 and column 3, 1, -1, 1, 5. Okay, so now doing the value for this would be +1 times 1 times the value of this determinant, which would be 23 as you do this downward product, minus -20. So that's 23 plus 20, that's 43. Okay, and then this next term would be -1 to an odd power is -1. -1 times 1 is -1 times the value of this minor determinant. So that would be -23 minus, and the upward product would be -4. Give myself much room there. Okay, so we have -23 plus 4. That's -19. -23 plus 4 is -19, but then that causes the -19 to switch to +19. Okay, then moving to this last value here, -1 to an even power is 1. 1 times -7 is -7 times the value of the minor determinant right next to it. So downward product first, followed by a minus sign. Upward product is -1. This turns out to be 5 plus 1, which is 6. 6 times negative 7 is negative 42. Okay, so d of z ends up being 43 minus 42 is 1. 1 plus 19, 20. Okay, so we finally have all of the values that we need in order to actually find the solutions. So as crazy as this may seem, we're still not done. Okay, so to finish this problem, as I stated at the very beginning of the problem, this is how you find solutions for any kind of a system using Cramer's rule. You have to do the determinant in terms of x. We have that, divided by the main determinant, the determinant in terms of y over the main determinant, and so forth. Okay, so let's go in for the actual final solutions. So to finish this, x is equal to, let's go grab those values. So for d of x, we got an 80. And for the main determinant value, we got a negative 20. So an 80 and a negative 20. Okay, for y, we're going to do, so this was d of x, this was d. Okay, so for this one, we're going to do d of y over d. So we already know that this is negative 20, and d of y also happened to be 80. So we'll just set that up, and then finally z is going to be the d of y value over the main d value. So that would be negative 20. D of y turned out to, or d of z, excuse me. D of z turned out, that was that last value we got, that was 20. Okay, so we now have x is equal to negative 4, y is equal to negative 4, and z is equal to negative 1. Okay, you can write it like this, or however they ask for you to write it. It can be written as an ordered triple x, y, and z, or you can just, they'll just say x is equal to, you fill in the answer. Okay, that, as painful as it was, completes number 10. Okay, the last one that I was asked to do is number 12. Number 12 is this problem where they tell you that the determinant value, they've already done the value of the determinant, and they're telling you that the value of this determinant is negative 2. So what you got to think is kind of think backwards. What is the procedure for getting the value of a determinant, which has just been demonstrated for you in numbers 8 as well as number 10? You expand it by the minors in order to get the value of a determinant. So you're going to spin back to how did they get this negative 2? By following the procedures that I just said in the last two problems. So this determinant was gotten in this manner. Starts with a negative 1, raise it to a power. We are grabbing row 1, column 1 in order to expand by the minors. What's in row 1, column 1 is an x. You add up these powers to get this power on the negative 1 and create the minor determinant by taking out row 1 and column 1. So take that out. Take out that column, that leaves you with negative 3, negative 1, and negative 1, negative 3. Okay, then moving on to the next term, start off with negative 1 again, just as I did in the last two problems. You will put a power there. Now we're grabbing row 1, column 2. Row 1, column 2. And what's the entry that's right there is a 1. By adding these subscripts, the 1 and the 2, you get the power on the negative 1, and it also helps you to construct the minor determinant. We're going to take out row 1, we're going to take out column 2. So taking out this row and all of this column, get rid of that, get rid of this, That leaves you with 4, negative 1, negative 1, negative 3. 4, negative 1, negative 1, negative 3. Okay, I'm going for the last one. So let's start off with negative 1 again. It will have a power suggested by this next entry that we grab, which will be row 1 now, column 3. Okay, what's in row 1, column 3 is another 1. Add up those subscripts, gives you the power on the negative 1 and helps you to get the minor. We're going to take out row 1 and column 3. Take out row 1, take out column 3. That leaves you with 4, negative 3, negative 1, negative 1. Okay, now calculate. Okay, coefficient times the value of the determinant. So negative 1 to an even power is 1. 1 times x is x times the value of the determinant. Do the downward product first, followed by a minus sign, then do the upward product, which is positive 1. Okay, then do the next one. Negative 1 to an odd power is negative 1. Negative 1 times 1 is negative 1 times the value of the determinant. Downward product is negative 12. Minus sign right away, and then this will be positive 1. Okay, moving into that last term. Negative 1 to an even power is 1. 1 times 1 is 1. So positive 1 times the value of the determinant. This would be negative 4 minus positive 3. Okay, now don't forget, all this work that I am listing out, that I'm detailing here, is showing how that negative 2 was achieved. So if this is the work that resulted in this solution, that means that all of this is equal to negative 2. Okay, so now we're going to get a little equation here. 9 take away 1 is 8. 8 times x is 8x. This would be negative 13, but this switches it to positive 13. Then this next term is plus negative 7 or just negative 7. So this leaves you with 8x. And then 13 take away 7 would be positive 6. Bring down that negative 2 and solve for x. So if you're going to solve for x, you're going to bring all constants to one side. So this is gone, leaving you with 8x on the right-hand side while having a negative 8 on the left-hand side. Divide by 8 on both sides, and you get a negative 1. Okay, and that is the solution for the last problem. Okay, that concludes the questions that you asked me, numbers 8, 10, and 12 from 11.3.